Hey everybody, Gene here, N7WDZ, and today I'm here to talk to you about the Pocket Pico TNC. Have you ever been curious or interested in amateur packet radio? Being able to communicate via live text or leave messages on your own or others' personal bulletin board service? Well, the Pocket Pico TNC allows you to do so in a fun and effortless way. So first, let's talk briefly about the Pocket Pico, what it does, and how we got here today. The Pocket Pico TNC allows you to connect to other amateur radio operators via VHF and chat real-time with text. If the station isn't available, you can leave a message on their personal bulletin board service, or BBS for short, and you can check your own personal bulletin board service for messages left for you. Most bulletin board services generally allow you to leave a message for any station so that station can retrieve the message later. So how did the Pocket Pico come to be? Well, for that we have to go back to the 1980s. The Heath Company produced the Pocket Packet, model HK21, a small personal TNC with personal bulletin board service, performing all the functions I just talked about. This slightly modified Heath Pocket Packet model HK21 is over 40 years old. It's connected to an HP Jornada personal computer from the early 1990s. One day Peter, KF7PSM, decided to write some code to emulate the HK21 and run it on Linux. That code he called TNC EMU, which stands for Terminal Node Controller Emulator. With that code and a software-based sound modem like Direwolf, a fully functional packet station and personal bulletin board service could run on a Raspberry Pi single board computer, just like you were using the HK21. This involved having to know some form of Linux and how to access and adjust a whole slew of settings via the command line. So in early 2025, we came across the Pico TNC project from the user Ermitas over on GitHub. His Pico TNC code and design is a simple KISS and APRS terminal node controller, or TNC for short. And it's flashed onto a $5 Raspberry Pi Pico board. This is a $5 Raspberry Pi Pico board. So Peter, KF7PSM, and I got together and we got to thinking, what if Peter could rework the TNC EMU code and merge it with the Pico TNC project to have a fully working packet radio TNC with personal bulletin board service and a KISS TNC, all on the one single $5 Raspberry Pi Pico board. Well, after a lot of research, a lot of development, a lot of coding, a lot of testing, a lot of late nights, early mornings, strong coffee, the Pocket Pico came to be. Schematics and component lists were made, printed circuit boards were designed, and while we waited for those printed circuit boards to be made, we had breadboarded circuits up and running, and we were using them for weeks. We even designed the Pocket Pico to use readily available radio interface cables you could just buy off the internet. Here's how easy it is to build a Pocket Pico and get on the air with packet radio. This is not meant to be a tutorial. That'll come later. This is just more of a what's involved to get a Pocket Pico up and running and on the air. First, you'll need a Raspberry Pi Pico. You can find them online as low as $5. Try to get one with the header pins already installed on it. It'll just make it easier later on. Next, you'll need a custom printed circuit board. You can download the Gerber files on the project's GitHub repository page to send to your favorite PCB board maker, or you can go to OSHPARK.com and search for Pico TNC EMU to order the Pocket Pico PC board directly. Links for both the GitHub repository and the OSHPARK website will be in the video description below. Next, acquire the required handful of basic electronic components from your favorite vendor, and then start populating the PC board by soldering on the components and the Pico. Follow the schematic and the component IDs which are printed on the printed circuit board for the correct placement of the components. You can solder the Pico directly to the PC board, or you can use a header socket. Okay, so say now you have the PC board and the Pico is attached. Next, it's time to flash the Pico with the TNC EMU code. Go to the project's GitHub repository page and download the pico_tnc.uf2 file onto your PC. Then plug a USB to USB micro cable into the PC. Press and hold the boot button on top of the Pico and plug the USB cord into the USB micro connector on the Pico. The PC will now see the Pico as a flash drive. Drag and drop the pico_tnc.uf2 file from the location you saved it onto the Pico flash drive. The window will close and the Pico will reboot. You will now have a working Pocket Pico packet radio station with personal bulletin board service and a KISS TNC. You're going to need a 2-meter FM radio and a cable to interface it to the Pocket Pico. The easiest way to do this is to decide on the radio you want to use and to order a ready-made cable from the DigiRig website. Or if you choose, you can pull the cable build diagram from DigiRig and roll your own cable. It's all up to you. If you want to 3D print a case for the Pocket Pico, we got you covered there too. On the project's GitHub repository page, you will find a couple of STL files you can use to 3D print a case if you are soldering the Pico directly to the circuit board or if you are using pin headers. Also on the GitHub repository, you'll find the SCAD file, which you can use to really customize a 3D printed case for such options as using pin sockets and custom Pico boards. Here are some custom boxes I printed up with SCAD to utilize a WaveShare Pico board style, which incorporates a backup battery. There's one on the bottom of this. So, very cool. So the Pocket Pico is built, it's connected to a radio in the PC. You might start to see the DCD LED illuminate or flicker. This means that it's hearing what it perceives as traffic. It may actually be hearing traffic if you're on the frequency. Oh, and by the way, the Pocket Pico works with open squelch, so you don't even need to set a squelch level. Okay, start your favorite terminal program. Here I am using Putty. Set up Putty to connect to the Pocket Pico via USB, and your Pocket Pico radio station is up and running. All you got to do is adjust a handful of settings in the Pocket Pico terminal window, and you're all set. Here I am connecting to the KF7 PSM mailbox and leaving him a message. Here I am leaving a message to check into the Aries weekly net. Here I am having a live station-to-station conversation with KF7 PSM. Okay, let's say there's a station I can't reach because they're just too far away, or I don't have RF line of sight to that station. For example, I can't reach the K7JNT packet station that's over 100 miles away in Washington, Utah. But I know outside of Las Vegas there are mountaintop packet nodes on Angel Peak and Utah Hill, which I can use to connect through to reach the K7JNT personal bulletin board. Here I connected to Angel Peak and then to Utah Hill. From Utah Hill, I'm going to connect to the K7JNT personal bulletin board. So I went from Las Vegas to Angel Peak to Utah Hill into Washington, Utah to connect to K7JNT, and here I'm going to leave them a message. And once I sent that message to K7JNT, I'll do a B command to disconnect from all the packet stations. This is a complete packet radio station. The widely used 2-meter packet radio frequency here in Las Vegas is 145.050 megahertz. All right, I want to make a quick mention of some of the options already available on the Pocket Pico. The Pocket Pico is operated from the USB connection or the 3.3 volt TTL serial connection, or both. The TTL 3.3 volt serial connection is helpful if you want to operate the Pocket Pico from a dumb terminal. There are 4 dip switches. One dip switch will turn off all LED activity should you find conserving power be necessary. This is useful for builds that use the wave share Pico with the external battery option, or if you power your Pocket Pico from a high capacity USB style battery pack. This here is the wave share style Pocket Pico, and it has a battery underneath the circuit board. The other 3 dip switches can be switched in various positions to enable console mode or CON or KISS mode on the USB or serial connections, or both. If the 2 KISS modes are being used, there is no console access, but the TNC EMU code can still run as a digipeater or a bulletin board service in the background. There is a 90+ page manual created, and it can be downloaded from the project's GitHub repository. The dip switch positions and associated functions can be found in the manual. Future updates to TNC EMU may include the ability to perform HF packet radio. We'll keep you informed if that actually happens. Well, that's a quick introduction to the Pocket Pico. Thanks for sticking around and watching the video this far. Let us know if you give the Pocket Pico a try. We'll probably produce some more quick how-to videos, maybe tutorial on building, more documentation. We'll see how it goes. In the meantime, here's some footage of the Pocket Pico running a packet radio bulletin board service on console while running packet Winlink on KISS, both at the same time. I'm Gene, N7WDZ, 7-3 to everybody. Have a great one. So here's the Pocket Pico, and I have USB connected and I have the serial TTL connection, both going to the computer. So I have the USB connection on COM9 going to the console or PuTTY, and here you can see I am connecting to the LV mesh network and just running an MH2 command to see what stations were heard on port 2 of the LV mesh network. As you saw, sound modem is still decoding packets from the console USB side, even though Winlink is using the serial connection. So the Pocket Pico USB connection is utilizing the console bulletin board packet station, and the serial connection on the Pocket Pico is utilizing the KISS function of the Pocket Pico and connecting to Winlink. Here you can see on Winlink I connected to the W7SCS-10 Winlink station to check for messages. This can all be reversed, where the Pocket Pico packet PBBS can be on the serial connection and the KISS TNC with Winlink can be on the USB connection.